All right, question 8 is given a function y of x equals x squared ln of x plus 5. Write the equation of the tangent to y of x at the point 1, comma 5. The equation of the tangent is basically the equation of a line in point form. If you remember, it's from previous maths. It's y minus y1 is equal to mx minus x1. You should memorize this. Because we're going to find a tangent to y of x and then we're going to put it in this form, and that's our final answer. So you guessed it, take the derivative as always. That's the whole point of this course. So this is a product rule, x squared times ln of x, and this is a constant, and it will go to 0. So product rule, derivative of the first times the second plus the first times the derivative of the second. So derivative of the first, 2x, times the second, plus the first, x squared, plus the first, times the derivative of the second, which is derivative of ln x is 1 over x. So simplifying, 2x ln x plus basically just x. Alright, and now we evaluate the derivative at the point 1, comma 5. That's our point. So we plug in restart bit. Alright guys, question 8 is asking us that given a function y of x equals x squared ln x plus 5, write the equation of the tangent to y of x at point 1, comma 5. So the equation of the tangent is the equation of a line, and that's in point form. If you remember, it's from the previous maths, it's y minus y1 is equal to mx minus x1. You should know this by heart. It's just a general formula for a line, equation of a line. So what we're going to have to do for this problem is we're going to have to take the derivative, you guessed it, as always, in calculus. And this is a simple product rule, and this is a constant, so it will go to 0. Product rule is derivative of the first times the second plus the first times the derivative of the second. So derivative of the first is 2x times the second, you don't do anything with it, plus the first times the derivative of the second. There you go, and that equals 2x ln x plus x. And now you got to find the slope, because the derivative is basically the slope. So if you were to plug in, if you try to find this right here, this is the slope. If you plug in your x value 1 into this equation here, you'll get the slope. So 2 times 1 ln of 1 plus 1 equals your slope. And that is equal to 1, because this is 0, and we're left with this. So our slope in this equation here is 1. So now we can start writing our, we have all the necessary things to fill out this formula. We have our coordinate, x value, y value, and our m. So our equation would be y minus 5 equals 1, x minus 1. And just bringing over the 5, our equation of the tangent is that. In other words, x plus 4. Alright, so part B of this question is asking us to evaluate y double prime at x equals 1. So we got to find y double prime, and here's our y prime. We already found it. It's 2x ln x plus x. To take the derivative, y double prime, let's put a barrier over here. So y prime, again, product rule, we got a term 1 and a term 2, 2x times ln x. And this will go to 1, the second term, derivative of x is 1. So again, product rule, derivative of the first times the second plus the first times the derivative of the second. So derivative of the first is 2 times the second, ln x plus the first times the derivative of the second, 1 over x, and plus 1 for the second term. And simplifying, we get 2 ln x plus 2 plus 1 is 3. And then it's asking us to evaluate at x equals 1 and y prime of 1 is equal to 2 ln 1 plus 3. ln 1 is 0, so that whole term is 0. Y double prime 1 is 3. That's our answer. Alright, now we've arrived at the big badass problem of the exam. This one has 4 parts and it ends up asking you to graph the actual function. So don't worry, we're going to have, through solving parts A, B, C, and D, we'll have all the tools necessary to graph the problem. I mean, again, it's straightforward, guys. It's just remembering what to do for finding certain things, like the intervals of increasing, the points of inflection, all that mumbo jumbo. So we'll take it one step at a time, explain what's going on, and figure it out. So, number 9, part A, given a function, find the intervals in which the function is increasing and decreasing. So to do that, you guessed it again, always take the derivative. I mean, you could just take the derivative right away as soon as possible. So f prime of x, so we'll bring the 3 to the front, we'll multiply by the 4, so it will be 4x squared minus 8x minus 12. That will be our derivative. And the next step would be to find the critical values like before. So when you find the critical values, those will help in finding the intervals of increasing and decreasing. So factoring this out, I'm just going to jump straight to it because you should be able to do this on your own. So here you see that x1 equals 3 and x2 equals -1. Alright, so what you're going to do now is you have a range over here. Let me just you have 2 zeros. I'm thinking of a better way to write this. I'm writing in this order so you can see it better. You have zeros here, okay, and you're gonna have to take the range from before this -1 and the range from -1 to 3 and the range from 3 to infinity, and you evaluate those. So you have your zeros, and our first zero is -1, so we'll take the range of -infinity all the way to -1. Our next range will be -1 to 3, and our last range will be 3 to infinity. So anytime you have zeros, you get the range before the first zero and between them and the range after. So what you're going to do is you're going to pick a point between these two, in this range, somewhere in this range, somewhere in this range, somewhere in this range. You're going to take that point, that value that you chose, plug it into your original formula. No, you're going to plug it into the derivative formula. And if that value is positive or negative, it'll tell you whether the function is increasing or decreasing at that range. So for like example, this range here, let's pick the value. Let's pick between -2 right here for this one, because that's in between. Let's pick 0 for this one, and let's pick, let's just say 4 for this one. Okay. Now, what is f prime of -2? Is it greater than 0 or less than 0? So plugging it into here, you can see that -2 squared is 4, so 16. So let's say, I'll write it here, f prime -2. So the first term is 16, and -2 times -8 is plus 16, minus 12 is 32, minus 12 is 20, so it's greater than 0. So f prime of -2 is greater than 0. That means on this interval, the function is increasing. So if you can find f prime of 0, f prime of 0 would give you 0 minus 12 and equals negative 12, which is less than 0. Then the function here is decreasing. And the same for 4, f of 4. F of 4 ends up giving you 16 times 4, 16, 32, 48, 64, minus 32, minus 12. That gives you a positive number as well. We'll say it's greater than 0, obviously. And so on this interval, it's increasing as well. And that's your answer. Usually you'll put it in this form here to satisfy your professor. That on that interval, union this interval, it's increasing. And on this interval, negative 1, 3, decreasing. So now let's move on to part B. Alright, so part B, so find a maximum minimum points. It's not giving us a defined range like the previous time we did this problem. So we're gonna we have to use the critical values that we found in part A, and the critical values we found were, if you remember, x1 equals negative 1 and x2 equals 3. So to find where the max points are, we're just gonna plug these into our original function and see what we get. And those will be our max and our min. Our original function was 4 by 3 x cubed minus 4x squared minus 12x minus 4. So if we plug in that negative 1, f of negative 1, we get 2 2/3, and if we plug in f3, we get 40, negative 40. So our max is located at the points negative 1, 2 2/3, and our min is located at the point 3 and negative 40. So let's move on to part C. Find the intervals in which f of x is concave up and concave down. So to do this, it's the same concept as finding the intervals where it increases and decreases, except you have to do it with the second derivative this time. So we found that f prime of x was equal to, in part A, we found this, 8x minus 12. F double prime of x is 8x minus 8. So what we do here is we solve for the 0 like before and set it equal to 0, 8x minus 1, and we find that our 0 for the, well, our critical value for the second derivative, is not 0, it's 1. And now we do, so we'll test a number before and right after our critical value. So let's choose the before value is 0. So f prime, double prime of 0 is equal to negative 8. And since it's less than 0, we conclude that it's concave down. And if we take a number after 1, such as 2, f double prime of 2 is greater than 0, so we can conclude that it's concave up. So basically, our final conclusion is that from negative infinity to our 0, it's concave down. and from 1 to infinity, it's concave up. So part D is asking you to find the points of inflection, if any. What you'll do for this is you'll work with the second derivative, and because you found that the critical values from the second derivative, there was only one, and we found it in the previous part. It was x equal to 1. That's the critical value for the second derivative. So what you do is you plug this critical value into the original f of x equation. That was f of x, 4 by 3, x cubed minus 4x squared minus 12 minus 4. Just before we do this, the point of inflection is the point where the curve goes from concave, changes concavity, I guess that's the word for it. So let's say I draw a function here, and it looks like this. The point where it's changing concavity should be like right here. You see that it's kind of like up here, and at this point it starts to go this way, right? The curve, so it's changing concavity, and that's the inflection point. So we take the critical value that we found from finding the zero of f double prime, and we plug it back to our first equation, the one that we didn't take any derivative of, and we find that f1 is equal to 4 by 3 minus 4 minus 12 minus 4. So we get negative 19 and a third. That's our inflection point. Alright, so now that we have all this information, we found the interval increasing, where it changes concavity, the max and min, we can actually plot this, and that's exactly what we're going to do in the last part of the problem. So let's just note that this point that we just found was 1 comma negative 19 and a third. Let's rewrite all the known data that we have. Inflection is that we've got the intervals of increasing, negative infinity to negative 1, union 3 to infinity, increasing, and negative 1 to 3 decreasing. Max point was negative 1 comma 2 and 2/3, and min 3 negative 40. Concave down on the interval negative infinity to 1, and up 1 to infinity. So now we got all this information, we can actually graph the problem. Alright, so let's change color for nice purposes. Draw a straight line here, straight line here. So what we can do first is we can, we know that our maximum point is at negative 1. We'll call this negative 1. We'll call this 2, 3. So our max is going to be somewhere around here. And our min we said was 3. So let's go 1, 2, 3. And negative 40, we'll just say it's like all the way down here. So our min will occur at this point here. Our inflection point will occur at 1, 1, and we'll say 19 over 3 is here. At this point, the concavity will change. So we can sketch the graph here. We can say that And we know on the interval from, let's call this negative infinity and infinity. From negative infinity to negative 1, from here to here, it's increasing. So we got to be increasing, and obviously we're going to increase all the way to our max, and that's that. And now from negative 1 to 3, we note that it's decreasing. So obviously we're going to go up to 3, decreasing, and we're going to reach our min at that point. It's not the best sketch, but we're going to reach our min over here. And then for the last 3 to infinity, we're just going to be increasing. So it's going to look a little bit like that. We don't know where it's going after that, but that's a rough sketch, and that's the general form of the graph. This was the inflection point. I forgot to pass through it, actually. That's wrong as well. So we'll say that at this point the concavity changes, which is correct, and then we increase back again. So that's the rough sketch of our graph. Max, min, inflection, and we followed what the information that we solved for, and it's just a sketch, so it doesn't have to look perfect. Don't worry about it. Alright, we're done with the hardest part of the exam. Well, it's not really the hardest part, but the most tedious part, I guess. So let's move on to question 10. Alright, so we arrived at our first word problem, and there's going to be a couple on the exam, just to cover all areas of calculus. So let's read the problem here. The weekly demand and cost functions for X units of a Samsung tablet model are given below. So the P of X formula is the weekly demand in dollars per item. Before we go any further, I just want to correct something in this formula. There's actually a mistake here. It should be x squared plus 180x. Okay. So that's the formula for the weekly demand, and the second one is the cost formula function in dollars for X units, the weekly cost. So use marginal profit to estimate the profit realized from selling the 201st unit. So if you look somewhere in your textbook on calculus, you'll see that for this section, the formula to solve this kind of problem is you're going to solve for P of X, big P of X, which is just the difference of the demand and cost function. So P of X minus C of X. So we'll get here negative 0.06x squared plus 180x plus 0.00, we're subtracting, right? So it will end up being minus 0.02002x cubed plus 0.02x squared plus 12. Simple derivative to take now. So the next step is to take the derivative of all that stuff. So we'll get 2 times negative 0.06 x plus 180 minus 3 times 0.0002 x squared plus 2 times 0.02 x. Alright, and then what you're going to do, guys, once you have the derivative, you're going to look for the profit from the 201st unit, which is your x value. But you're not going to put 201st in the formula. You're going to put the one before. So whenever you see a problem like that asking for the profit of the x unit, you take x minus 1 unit. That will give you the actual profit from selling the 201st unit. It's just the way it is. So you plug in 200 here, and if you plug it in here, here, and here, you'll get a value of $128. Part B of the question is going to ask you to find the production level X that gives the maximum profit. The key word here is maximum. Whenever you see a maximum, the word maximum in calculus, it means you're going to have to set the derivative to 0. So if we go ahead and do that, we're going to set p prime of x equal to 0, and then we solve for the x values, we get the production level x that gives the maximum profit. So we have our formula here. If we set 2 times negative 0.06 x plus 180 minus 3, 0.0002 x squared x, if we set it to 0, and you can solve this using the quadratic equation, just simplify it further, and you'll have it in the form x squared plus ax plus b, ax squared plus bx plus c. Use the quadratic equation, or however method you wish, and you'll get that x is equal to 467. And that is the production level that is needed to give maximum profit. Alright, let's move on to the next word problem, and that's here, number 11. A rectangular box with a square base like the one shown below has a total capacity of 20 centimeters cubed. If a material for the top costs $2 per centimeter cubed, the material for the sides costs $10 per centimeter squared. And the material for the base costs $3 per centimeter squared. Determine the dimensions x and y of the box that can be constructed at minimum cost. Alright, so we have a prism here, rectangular. Make sure you note that it looks like a cube, but it's not. The x and y have are different sides. So we're given dollar values of each side. We're given a volume. The total volume of this cube is 20. I said cube, it's not a cube. This prism is 20 centimeters cubed. So we can write a formula of the cost of this whole cube if you input certain x and y values right away. So look, so we'll call it cost. That's a function of x and y. And let's go line by line here. The material for the top costs $2 per centimeter squared. Centimeter squared is area, so we'll find the area of the top and multiply it by $2. That'll cover the cost of the top. So we got our $2, and then we multiply it by the area of the top. And the area has, the dimensions of the top is x and x, so x squared. Length times width. And let's work on the sides. So we got $10 per centimeter squared, and the area of the side is x times y. So $10 x times y. But don't forget we have 4 sides, right? So times 4. And then we have to cover the base, which is $3 x squared. This gives us a final cost formula of 5x squared plus 40xy. This is not the complete formula for the cost. You still have to add in this volume factor here. And we know that volume is found by, for this specific figure, it's the area of the base times the height, right? So x squared times y is equal to 20. So now if we isolate for y, we can actually have a value for y to plug in over here. So you know that y is equal to 20 by x squared. Now let's rewrite this cost function here, which is only in terms of y, x right now, because we have a value for the y. So plugging that in, we get 5x squared plus 40x times 20 by x squared, giving us the final formula of 800 by x. Alright, so now it's asking us to determine the dimensions x and y of the box that can be constructed at minimum cost. Minimum and maximum in calculus means take the derivative, set it equal to 0. So if we were to take the derivative of this function, we would get 10x minus 800 over x squared. Should know how to do that. And we set it equal to 0. And solving for x in this equation, I encourage you to try, would give you the third root of 80. And now you got to find y, right? What's more simple? What's the simplest way to find y? Is you would I mean, you could plug it in here, but it's kind of annoying. But you'd plug it here in this one. It's so simple, right? So y would be 20 by third root of 80. And these are your final answers. These are the dimensions that would minimize the cost. Alright, no calculus introductory course is complete without solving a few integrals. Final exam will include a couple of integrals testing the various methods that you learned. The first one is the easiest here. It's the integral of 3x to the power 4 plus 3x minus 1 over x cubed dx. So how will we go about this? Looks complicated, but no, it's not really at all. You can actually, you have 3 terms in the numerator and 1 in the denominator. You can actually do term-wise division and end up with 3 separate integrals. So property of integrals is you can distribute the integral to each term. So if we divide each term in the numerator by the denominator, we'll have the integral of this term plus the integral of 3x over x cubed minus the integral of 1 over x cubed. There's a dx on all of them. And then we can simplify, cancel out some of the x values. We get 3x plus the integral of 3 over x squared minus the integral of 1 over x cubed. And there's a dx on each of them, but I'm not going to add it right here. So a couple properties of integrals, not properties, but the most basic integrals to note is that the integral of x, so you have an invisible exponent here, it's 1, so you add a 1 to the exponent, and then you divide by the new exponent. That's the integral of x. The integral of, let's say, 1 over x squared is the same as writing x to the negative 2. You bring the x squared to the numerator, and you change the sign of the exponent. And that would be the same count. Now we're in the same done in the same manner as the integral of x. You add a 1 to the exponent, so you'll have negative 1, and you divide by the new exponent, negative 1, which ends up equaling 1 over x. Okay, so let's apply these concepts to the integral here. So the first one, sorry about that. The first one would be 3, because you can bring the 3, you can bring it out in front of the integral. So you have the x value, you add a 1 to it, so you have a 2, and you'll divide by 2. And this second integral here, let's do it at the bottom over here, just to show you. So you'd bring the x squared to the numerator, add a 1 to the exponent, 3x to negative 1, and divide by negative 1. It's a negative here, I forgot that. So you'd have negative 3 over x. So that's negative 3 over x. And the last integral would be, let's do it at the bottom here in pink, magenta, whatever. So 1 over x cubed, you'd have you'd have x to the negative 3 if you brought it to the top. Add a 1 to it, x to the negative 2, and divide by the exponent. So you have 1 over 2x squared. Right? So you would mind, it's a negative, right? So you plus, because we have a negative term over here, so plus 1 over 2x squared. You have to tack on a constant, because we're doing something called an indefinite integral. There's no bounds. There's usually a bounds here, a and b, but in this case there's none, so we don't have a value for c. So this is our final answer for this integral. And this is equal to your original function. When you take the integral of something, you're going to get back the original function. When you take the derivative of a function, you're going to get the derivative of the function. So integrals are going backwards. Alright, let's move on to the next question. Alright, so we finally arrived at the last question of the exam. It's somewhat harder integral to do, but still it's easy once you know the method. So when you have integrals in this form, a term multiplied by another term, you're going to think of the product rule for some reason because you're used to it. But no, there's no product rule here. It's this is an integral, not a derivative, so don't get confused here. So we have a simple term x multiplied by a more complex term here because it's to the power of 6. Whenever you have something in brackets to raise to a weird exponent that you don't usually see, like 7 or something, you'll want to make a substitution. This is the method we're going to use is substitution. So you'll rewrite this as the integral of x, and we'll call u is equal to 2x squared minus 4, which means this new integral will be x multiplied by u to the power of 6 dx. We can't really integrate this because we have a u here and we have a dx here. We can't have two different variables here and an integration factor dx. We need to either get rid of this, because we're working in u's now, we want to work in u. To simplify the problem, we got to get du over here. So the only way to get du is by taking the derivative of this u. So you get 4x. And so that covers that. But we have to get this du inside this formula, right? So if we isolate it here for x, and then plug that in here, we would have du by 4 times u6. And the dx, we'll just get rid of it because we can't integrate with dx anymore because we have no more x's. So let's just put this in the, a similar form to the original question. So it would be the integral of, so it would be 1 by 4 u6 and bring the du to the back. Now it looks like the original problem except all with respect to u. So we can bring the 1/4 out to the front and just do the integral of very basic integral. Just add 1 to the exponent and divide by the new exponent, which would be u to the power of 7 over 28 plus the constant. Don't forget the constant here because we have an indefinite integral. And then you just plug back in your original value of u, all to the power of 7 over 28 plus c. Easy as pie, right? Just remember this trick, right? Make the substitution, take the derivative of the new variable, and isolate. Put it all in terms of u, and there you go. That concludes the final exam. It's going to be broken up to 7 parts, so I hope you can watch it all, and I hope you guys do really well on your Calculus 1 exam. Stay tuned because Calculus 2 exam will be out very soon, and that's all about integrals. It's more fun. So I wish you guys the very best. Please smash that thumbs up button and subscribe to me. I will have many videos that hopefully will help you out through your school careers. I hope you share this video so that many people can learn something and get help. I know that I used video help when I was in school and it greatly assisted me. So I wish to pay it forward. So I'll see you guys in the next video.